Hello everyone, and I welcome you all to this lecture, which will be all about the U-Turn NAT. Now, just to make you understand what U-Turn NAT is, so basically, we have this couple of what do you say, a user here. Let's say these two users, out of which I will just take this user, and let's say it wants to access a application which is on www dot say zbnetworks.com. Now there can be two scenarios, right? One, I have the the DNS inside my org, or I have the DNS on the public side somewhere here. Okay, in this case, like, so this will be different, right? In this case, what will happen if the DNS is inside my organizations, the DNS query will reach the DNS server, and then this www.zbnetworks.com will be translated to an IP address, right? An IP address. I'll get the IP address of that URL application, and let's say this application is on my DMZ side. This is my DMZ, and this is basically on 172.16.31.0/24 subnet, and this is on maybe let's say 51. Okay, so I'll get an IP address, let's say 172.16.31.51 for this application. Now in this case, what I need is my traffic will go to the firewall. Now on the firewall, what I need is a security policy, right, which allows the inside or the trust to the DMZ segment. That's the policy I need, because routing is already in place because this will be connected. If it's not connected, then you need the routing as well for the DMZ segment. All right. So this is the case when you have the DNS inside your organization. Now, let's say this DNS is outside your organization. So again, I need to visit zbnetworks.com, right? Now this time what will happen is this will send a request outside the org, and I should have a policy here which says allow DNS, right? That particular application has to be allowed from inside to outside. Now that uh, what do you say, the request reaches the DNS on my public domain, can be here, right? So reaches here, and it gets a reply back with the IP address. Now IP address has to be on the outside public IP in this case, because anybody who is on the internet, any user, right, any user who is on the internet, when he wants to access this www.zbnetworks.com, okay, zbnetworks.com, you cannot hand it over a private IP, nothing like this 31.51, right? The earlier case, not possible. This is not routable. Now in this case, that means I am having a NAT on my outside interface of the Palo Alto firewall, or maybe on a public address, which basically is serving that application. Now in back end, there will be a destination NAT happening. That is a different case, but let's say it gets that IP address. Okay, of that, let's say for this one is 123.1.1.55, let's say. So this IP is on the public address, on the public segment, denoting this server, this application of www.zapbnetworks.com. Now in this case, what happens, the traffic went outside, the red traffic went outside, and the return traffic now is going to from this now from this one, right? It went outside. Now then what will happen is it will get the IP address, it will go out and hit on the public IP, and then go in back to the DMZ. Okay, let me just again do this. So it is going outside, hitting this public IP, and then going into the DMZ zone, like this. So this is called a U-turn NAT. Now in this case, right, it's taking a U-turn from your firewall. This is your firewall and it's taking a U-turn. So this is called, that's why you have the U-turn NAT specified here, because it looks like a U-turn here. So these are the cases. Now in this case you have two scenarios, right? The DNS is inside. In the case that the DNS is inside, you don't need the U-turn NAT. Now in the case the DNS is outside, then you obviously need the U-turn NAT. And also, maybe even if you have the DNS inside, there is no DNS entry for this application with a private IP, right? Maybe the inside DNS also is handing over you a public IP. So in that case also there will be a U-turn NAT required. Now it depends on organization to organization how they want to do this, how much access they want to give that particular application inside the organization, and how they want the people to access that particular application, whether it's an inside user or a public user. So now you understood the whole concept of a U-turn NAT. Now it's basically a U-turn NAT is just a concept, right? And how you implement is what you need to understand. Now other firewalls also have this concept. In ASA this is used to called as double NAT. Okay, or you can also say twice NAT. Now this can also have multiple implementations, right? You will see in a moment. Now let's say what is happening. Now in this case this user is 10.1.1.51. this is my source. Okay, now destination after the what do you say DNS resolve 123.55. This is my this segment, correct? Now once I hit this IP, what should happen? What should happen is, now my source, obviously I will have a source NAT because I will not be sending my private users outside. So I will have a source NAT which will translate this source to, let's say, to the IP of the interface. Say 201 is my interface of the of this Palo Alto Firewall, and the destination I have to now change to 172.16.31 dot what was that, let's say 51. Okay, so this is my this is the normal scenario, right? Now in this case if you have a DNAT which is getting translated to this one, that might work, but this should be hitting my destination address. Now this will not work, right? So how it is going to work is, you will specify the source, you will specify the destination, you will specify the zones as well, now inside to DMZ like that. But in this case what will happen, the source has to be translated to the DMZ interface. Okay, so that is going to be, let's say, 172.16.31.201. so in this case if it is like this 201, all right, and then the destination has to be 172.16.31.51. now this is going to work because once this PC, the server, application server, right, app server, receives this, he knows that it's the local network, right? So it can send the traffic back. Now in this case, even if this is a dumb device that does not know routing, this is also going to work. So this is one of the implementations as well. If you see, right, if you have a legacy device that is not supporting routing, or even you don't have option to specify a default gateway. I mean, you do have devices as of now also in today's network that does not support the configuration of the default gateway. Okay, in that case also this is going to work, because this device is going to think as this is a local traffic from the same subnet, right? So this is going to work. Now once the traffic is returned back, it is going to untranslate the traffic, and again the source is going to be this and the destination is going to be this. So we will see all this in the captures as well as in the logs. We will see all these things happening, and we'll verify that it is same as what I have told you, right? So this is the whole concept of the U-turn NAT, and this is what we have to do. So now let's go on and lab it up and verify the U-turn NAT concept and how it is configured. Okay, now so we are here in the lab, and now we will see how to implement this U-turn NAT here. So I have this VPC, which will consider as the DMZ server. If I go on this one, I have the if I check show IP, it has no IP. So let me set the IP as 172.16.31.51. Okay, so I can define the gateway as well, but in this case we don't need the gateway because I will be uh, changing the source to the same local 172.16.31 some IP, right? But you can also have the gateway defined, for example 172.16.31 say 201 is my gateway, which will be the IP address of the interface on the DMZ of Palo Alto Firewall, right? 201. So if I check the show IP now, I should have the default gateway mentioned as this IP. So this is done. Now on the switch side, I will configure the G02 and G1/3 as part of the DMZ VLAN, which can be any hmm, what do you say, VLAN number. Show VLAN. If I see now, I have configured the VLAN 172 as the DMZ VLAN, and I made this G02 and G1/3 as the access port and part of this VLAN. So that is all I need on the switch side. All right, and okay, so let's go to the firewall and configure the DMZ interface here. So I'm in the firewall. Let me log in. So the interface here is 1/5 of the Palo Alto Firewall. So I'll go to the network tab, and on the interfaces, I'll click on ETH1/5. I'll name this as say DMZ, just a description. Interface type I have to change to layer 3, and then I need the virtual router, which is going to be the default virtual router, and a security zone. So you need to create a DMZ security zone. That should be an L3 zone, and I will select it here. Now on the IPv4, I will have to define the IPv4, which is 172.16.31.201/24 is going to be my IP on that interface. IPv6 I don't need. I'll go directly to the advanced, and I will apply a management profile which will allow me to test or ping on this interface, right? So that's all that I need on this interface. I'll just go and commit the changes here. All right. Let me go ahead and create an object. Let's say like this. I will create an object of my DMZ server name, DMZ server. Okay, and IP is 172.16.31. Let's say 51/32. Okay, so again I will go and commit this, and if I go here and check my task, so I have one queued, one is almost completed. So I can go to my this PC and try to ping the DMZ IP. It's 240. So I think I already have the putty running. Yeah. So this is my this, and I'll just ping the 172.16.31. 51, I guess. 51 is myself, 201 is the firewall DMZ IP. Okay, so that is reachable. Great. So now the idea is that I should ping this IP, which is 123.1.1. Let's say what, 255. Okay, let me just add and log, and let's say text. This is my VIP, or I can say virtual IP 123.1.1.55. This is going to be my virtual IP on the outside. Okay, to reach this 172.16.31.51. Okay, so I should ping this IP and I should get a reply from this VPC. Okay, in this case, let me just capture two interfaces, which is ETH11 and ETH15. Okay, let me just capture ETH11, which is going to be my inside, and then I will capture the ETH1/5 capture, which is going to be my DMZ side. Okay, very good. So if I see now, let's say if I go to my Windows, okay, and let me try and ping this IP, which as of now nobody owns. I should not get any response. 170, sorry, not 172. It should be 123.1.1.55. 55. Okay, so I'm not getting any responses because nobody is basically listening on that, right? So I'll go here, and on one interface I should see this ICMP. If I see, yeah, 1050 10151 trying to reach this. Okay, so this was the ping that I generated just now. Okay, and on the DMZ side, obviously there will be nothing which is on the ICMP. All right, it's clear. Okay, so now what we will do, now to do this, you would need to go to the NAT option. Okay, inside the policies, I have this LAN to untrust, which allows my inside user to go outside. Even if I check the monitor, I should see that ping, right, that I was just about to tell you. So what is happening, let's see there. But getting natted, source NAT is to this one, but I don't want the source NAT to happen on this one. Instead I want this to source NAT to 172.16.31.201, right? In destination NAT also should change the IP to 172.16.31.51, which is the DMZ server. So in order to do that, what I will do is I will create an NAT policy. Now once you're here, I will add a NAT. Now in this case, let's say this is my U-Turn NAT. Okay, okay, and now on the original packet, what I will mention is add source as the trust. Okay, destination source is my DMZ. All right, any source, I mean any interface. So source address is going to be my LAN subnet, which is 10.1.1.0/24. Destination address is going to be my DMZ server. Make sure you have the DMZ server here, right? Now the problem is this is my private IP. I need the public DMZ server, virtual IP. That is what I need to define here, right? So I will add. I don't have a. Let's define an address. Okay, this is my DMZ server public. Okay, this is my 123.1.1.55. Okay, done. So this is what I want. Okay, on the original packet. Okay, and then the translated packet, two things I need to do. I need to do the dynamic IP port. Okay, and this I will translate to the interface, and that is going to be my DMZ interface, which is Ethernet 1/5 for the source. Now you remember, right? This should be our source, and destination should be our server static IP. Okay, this has to be translated to 170.16.31.51. So now you understand this looking at the source and destination that we were talking about in the previous explanation, right? So this is going to be my source, this is going to be my destination. It is the translated packet. Original packet is going to be go from my trust to destination DMZ. Okay, and this is the whole packet like this. All right, apply, and now then commit. Great. Now we will check this after this policy is committed, but I know that this is not going to work, but I want you to see, and we will see how much verification can be done as of now, to understand where this is getting stuck or what needs to be corrected here. But I hope you got what I have done till now. This is just the things that I've explained in the explanation of this U-turn, and that what we have implemented as of now. Okay, so let me check what is the percentage on the commit. Okay, great, done, good. So if I go to monitor, and now if I try from my Windows PC to do the same ping, do I see anything? That is what I want to see. Mm, okay. No, I'm not able to see anything as of now. And on the, yeah, here I can see that I have specified. So this is the source and destination. And on the other side, no, I don't see anything here. All right. So this is kind of, where there is no visibility, but what needs to be done here is you have to create a policy here. Now what I have is already I have the source trust to untrust. I'll just add the DMZ zone here. That's it. Okay, on the policy. See, I have this LAN to untrust. So I'll just go onto the untrust and add the DMZ as well here. Okay, so that's all I will do to add this to the security policy. Now let's wait for this to complete, and we'll test the pings. Now let me do a continuous ping here. And on the other side, let me just filter with ICMP here. And let me check the commit percentage. Should be something that I receive here. Okay, so first thing first, I need to do a reset here and see if the hit counts are getting, yes, I can see hit counts increasing. And I don't see any ICMP on the DMZ side. Now on the NAT, I want to see if I am having any hits on the U-turn. So I'm not having any hits on the U-turn. I suppose I have done the DMZ as wrong. So let me try the untrust here. Let me check the percentage of a commit. Okay, still committing the changes to the running config. All right. Few more seconds and they should start working. All right, I have the commit here. Now I want to see the NAT happening. Okay. All right, I have to check what is going on. I'm not able to ping. This is continuously timed out. So on the U-turn NAT, everything looks perfect, right? original packet is trust going to untrust. Earlier I mentioned DMZ, which was wrong, but untrust, if you see from here point of view of this user, he is going to a public address, right, which is on the untrust. So firewall, after receiving all this, checking the policy and that, then it is going to translate it and send it to the DMZ server. Now here this is fine. I'm specifying my source, which is the LAN subnet. I can specify the particular Windows PC. I have that Windows PC also here, but let's say the subnet itself for now. Then the DMZ server public IP, which is 123.1.155, that is also correct. Translated IP, I am translating the source to the DMZ IP of the Palo Alto Firewall, and then the destination is going to be my DMZ server private IP. So this is perfectly fine. Also on the security policy, I have this right. This covers everything. LAN subnet covers the PC, the server, everything. So I'm right now accessing through the PC. So I've added the DMZ here as well. Application everything is fine. What could be wrong? So when I go to this, I see no hits here, which is strange. And if I go to my filter here, I can see from obviously from this PC to the that 123.1.1.5 it is there, but on the server side nothing is there. All right. Okay, now I got the issue. So what is happening here is, if you see, this top one is getting all the hit counts and this is not getting hit, right? So if you imagine the firewall, when it's getting this traffic, the first rule is hitting and it's translating the source to 123.1.1.2.0.1 and not to this one, because this is the second one, but the first is covering itself, so second is not getting the traffic. So this is kind of a good example that the placement of the rule is very, very important, right? Because that rule U-Turn NAT is not getting hit. This is more specific, so this should be on the top, and then the general ones should be in the bottom. So if you want to see this, what we can do is go to the monitor and open any packet, this one, right? Open this one, and if you see the source, yeah, this is what I wanted to see. So my I mean, thinking was right. This should have been, in our case, if it was a U-Turn NAT, then it should be 172.16.31.201 instead one. So this is hitting on the first rule. That's why it's getting translated to that. And then obviously because of that, we don't have anyone who's responding on that, right? Great. So this is what is happening. So all right, I have made the changes here and I will commit it now. Did I? Okay, I need to change. Okay, I need to move this to up. Great. Now I'll commit this. Once I do this, everything should be fine. All right. So great. We'll wait for this to commit successfully. And yeah, once this is done, I am already pinging from my server, and this should start the ping. So I have filtered ICMP here. I have filtered ICMP here. And this side we already know, so we are not concerned about this. We are concerned about the other side. So we should see that source and destination both getting translated, and also any moment. Yes, correct. So we have the pings successful. So we'll go here. This is the request, right? If we open this, if you see the source here, the source is going to be 172.16.31.201, and the destination now changed to 16.31.51, which is our DMZ server. Great. So yeah, this is something that you needed to verify source and destination. All right, so I can stop this. All right, so I'll also stop this. Great. So I'll close this. I'll go to the monitor now. I can check this, open this, and this should show us the new translated NAT IP of the source and the destination. So here you can verify that whatever I was um, talking about is practically happening. And also, if you go to the session browser, you should see both the flows. So 12355, the first flow, right? It is going from 10.11.51 to 123.11.55, the public IP, and the second flow is coming from the source as 51, the server responding to 201, and in between the Palo Alto is doing the natting there, taking care of the translation and untranslation. All right, so that is how you implement the U-Turn NAT on the Palo Alto, and that was the whole concept of U-Turn NAT. Hope you learned something new today, and that was all for this video, and I will see you in the next lecture. Till then, bye bye.